Hello students, today we are going to see something interesting question. Prove alcohols are acidic in nature. Alcohols are weaker acid than water. How to prove? Chemical properties are important to note to that. Okay, chemical properties. Alcohols are versatile compound. That means alcohols acting as a nucleophile as well as electrophile. Okay, now here to prove this, three important points to be noted. That okay, what are those three importance? Generally alkyl attached with OH group, isn't it? So here the reaction involving cleavage of bond between oxygen and hydrogen, cleavage of bond between oxygen and hydrogen, that is one. And reaction involving cleavage of hydroxyl group, that is the second one. And third one, reaction involving cleavage of carbon and oxygen. These are the 3 points to be noted down. Okay, in that point, hydrogen, removal of hydrogen, that means cleavage of bond between oxygen and hydrogen. That point only we are going to see for proving method. Okay, now generally alcohol reacts with metal, base metal. Okay, alcohol reacts with base metal and it releases hydrogen. Okay, so in that way we can prove that it is a acidic in nature. How to say in acidic in nature? Now as we are looking at that equation only we will come to know. Okay, now here ethyl alcohol CH3 CH2OH combined with strong base metal Na. Okay, it gives what it is: CH3 CH2 ONA, sodium ethoxide, and which is releases out hydrogen, liberates out. Now here to here, yes. Okay, now not only sodium, potassium, magnesium, calcium, aluminum, all these metals reacts with what it is: alcohol. You are getting which is liberates out hydrogen, liberates out. Good. Okay, now here for example CH3 CH2OH combined with the magnesium, what you will get it: CH3 CH2O twice Mg. Why? That valency is 2, right? Got it? Yes. Now we'll go for tertiary alcohol. CH3, 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 here OH combined with the aluminium. Okay. Now here CH3, C, CH3, CH3, O, thrice Al. You know why? Because the valency it is that you have to check out. Okay, now here and here and H2, right? It liberates. So from that what we can make out: here sodium ethoxide, here also magnesium ethoxide, here here, aluminium tertiary butoxide, 1, 2, 3, 4. So, aluminium tertiary butoxide. Okay, now here, how do we identify how to identify that it is a basic in nature? Generally, ROH. Here, lone pair of electrons are there combined with the base. Okay, so what happened here? It is ready to donate the proton. Which is ready to donate the proton? Alcohol is ready to donate the proton. So automatically you are getting RO here, conjugate base. It will become what it is: conjugate base. And here this BH, it will become conjugate acid. So this ethoxide, alkoxide acts as a conjugate base because alcohol, it is donating that proton. When it is donating that proton, alcohol acts as a Bronsted acid. So naturally it is a acidic in nature. When it is donated to the proton, naturally 100% it is a acidic in nature. So in that way we can identify. Okay, now this alkoxide again, it reacts with water. it forms alcohol. This alkoxide, again it reacts with water, we are getting alcohol. But in that, which is acting as a strong acid, strong base? That is the question. That is what interrelated I just mentioned. Okay, come on, let us go and find out. Now, alcohol is ready to donate one proton, that is H plus ion, to the base, strong base. That is what alcohol acts as a Bronsted acid I just mentioned. So, what is the product you are getting? Alkoxide. Okay. Alkoxide is also known as conjugate base, and you are getting conjugate acid. Now, this alkoxide combined with water, again you are getting alcohol. But here that alkoxide reacts with water, no, that water molecule hydrogen, that is actually a better donor comparatively alcohol. Here, that is the second point we are proving. Okay, first point, because it is donating that proton to that base, so we are telling it is a acidic in nature. Yes, we proved. The second point, weaker acid than water. So alkoxide combined with water molecule, you are getting alcohol. But comparatively, this alcohol and here water, so it is ready to donate the proton. It is better donor comparatively alcohol. How do we say it's a better donor? Water is a better donor of proton than alcohol, or else water is a strong acid than alcohol, we can say. Or else, one more point, alkoxide is a strong base than OH minus ion, sodium hydroxide or potassium hydroxide, anything. So, alkoxide ion, it is strong base than sodium hydroxide. We can say in that way also. Okay, fine. Now, in this, one more point I would like to mention, the acidic strength. According to that acidic strength, primary, secondary, tertiary, in that way we can go and identify. Before that, just I'd like to mention here ROH. So here, hydrogen, oxygen. So water molecules. This is water molecules. This is alcohol. So alkyl groups, which is releasing the electron towards that oxygen. The same way, oxygen is pulling the electron towards from that hydrogen, right? So both this side, it is where the electron density, it is more strong in oxygen atom. When we are comparing this point, here oxygen is there, it's pulling towards from that hydrogen bond between that, what it is, hydrogen and oxygen, that is more stronger, so it is ready to donate one proton towards that alcohol point. So that is the way we can identify why water is strong acid than alcohol, or alcohols are weaker acid than water. One thing, it is ready to accept the proton. One point we can say, it's a ready to alkoxide, it's ready to accept the proton from water, or else it is ready to donate that proton to that towards what it is, alcohol. And here, primary, secondary, tertiary. Okay, primary, secondary, tertiary, the acidic strength. So the acidic strength, which is increasing or decreasing towards that alcohol, primary, secondary, tertiary, it is decreasing. See, primary, it's bigger than secondary, it's bigger than tertiary, so we can identify. Actually, this is proving method. 3 mark question, they may ask that question. Okay, hope you're clear with it. Why is it acidic in nature? So alcohol reacts with strong base metal, you are getting hydrogen, because alcohol, it's ready to donate one proton towards that. Okay, now another point, what alcohol or weaker acid than water, because alkoxide, it is ready to accept the proton from water molecule, as well as water, it is ready to donate the proton, ready to donate the better donor, we can say. Hope you're clear with it. Okay, we'll go some other question related to this topic. Esterification, it's very, very important reaction. It is so simple. Alcohol reacts with carboxylic acid. You are getting ester. That is very simple one. Carboxylic acid, what is the formula? C double bond O, OH. So this is carboxylic acid. Combined with alcohol, what is it, alcohol? or OH in the presence of, that is very important. Here it is dehydrating agent, concentrated H2SO4, concentrated H2SO4. It is a dehydrating agent. Also it is a removal of water. Now what happened here? Removal of water. Yeah. Okay. Now what is the, we are getting R C double bond O, here O R. So this is the formula for ester. Okay, now here what it is, actually it is acting as a dehydrating agent, so removal of water, so you will get water. Right, now for example, CH3 COOH, acetic acid combined with C2H5OH in the presence of concentrated sulfuric acid. Concentrated sulfuric acid, what it is acting? Acting as a remove a dehydrating agent. Dehydrating agent, it is removal of water. Okay, now what happened here? The same way you can put it, OH from here and hydrogen from here. Why I mentioned hydrogen from here? Cleavage of oxygen and hydrogen bond. Oxygen, from oxygen hydrogen bond, it is moving away. That is the reason I just put it H from here and OH from here. So water molecules, that is because of what it is concentrated sulfuric acid. So you are getting CH3 COO C2H5 methyl ethanoate. Now the next one, it is oxidation method. Alcohol undergoes oxidation, you are getting aldehyde. Further oxidation, you are getting carboxylic acid. So we are using oxidizing agent. What are the oxidizing agent? PCC, pyridinium chlorochromate. Pyridinium chlorochromate, it is nothing. Pyridine with chromium oxide along with HCl. So that is a complex formation, and chromium oxide, anhydrous chromium oxide, and alkaline KMnO4. So these are the three we are using that strong oxidizing agent. Okay, now generally ROH combined with the oxidation method, you are getting minus H2O. That means we are removal of water molecules. So here you are getting RCHO. Further oxidation, this is general one. So RCOOH. Okay, now here also water removal. Okay, now here CH3 CH2OH. We are taking ethyl alcohol with strong oxidizing agent we are using. You know, strong oxidizing alkaline KMnO4, I would like to take it. So alkaline KMnO4. So what you are getting directly, CH3 COOH. Acetic acid only directly you are getting, instead of coming for this point, directly you are getting acetic acid. Okay, now butyl alcohol, I just to take butyl alcohol, CH3 CH2 CH2 CH2OH. Butyl alcohol undergoes oxidation in what it is, PCC. We just take the PCC. Here you will get how many carbons are there. According to that, you will get aldehyde formation. Here CH3 CH2, here CH2 C double bond O H, aldehyde. So 1 2 3 4. Here one water molecules will be removed. Okay, so here minus H2O. So this is the way you can identify. Butyl alcohol means 1, 2, 3, and CHO. Here, what is it? What is the formula? Can you give that name? Okay, now next one. Isopropyl alcohol. CH3, CH, here OH, CH3. Okay, now in that oxidation process, here I would like to take anhydrous CrO3, chromium oxide, anhydrous chromium oxide. So what is the product you will receive? Here also minus H2O. So what you will get it? CH3 C double bond OCH3. Now you see here ketone formation, isopropyl alcohol. Now you see that isopropyl alcohol undergoes oxidation in the presence of chromium, anhydrous chromium oxide. You are getting ketone. That is what it is. methyl dimethyl ketone formation you are getting. Hope you're clear with that. Yes. Now we are coming to this dehydrogenation method. Dehydrogenation means a removal of hydrogen. Dehydration means removal of water. Please remember, dehydrogenation means removal of hydrogen. Dehydration means removal of water. Now that is coming under cleavage of OH bond. Okay. Now coming to that point, so primary, secondary, tertiary. Here there is one important give reason question is there. End of that point I would like to mention. When it is coming to the tertiary alcohol, I will mention that. Okay, now primary alcohol undergoes this copper along copper catalyst when you pass that red hot heat. So what happens, you will get aldehyde only. So primary alcohol CH3 CH2 OH, so it undergoes what it is, Cu copper catalyst with 573 Kelvin. Okay, you are giving the temperature to that this hot copper, it's passed over that alcohol. So what is the product you are receiving? Aldehyde CH3CHO plus hydrogen will be removed. Okay, now here another one more. This is primary alcohol, CH, secondary alcohol CH3 CHOH CH3. Okay, now here propane to all, also you can say isopropyl alcohol, also you can say the same Cu 573 Kelvin. So copper catalyst passed over that red hot, you are giving the temperature of copper, that catalyst is passed over to this alcohol. So what is the product you are receiving? CH3 C double bond O CH3. So you are getting what it is, ketone formation. Now hydrogen is released. Now tertiary alcohol will not take part in that dehydrogenation. Here it will take it for dehydration. I just mentioned, no? So here this and this it will take it for dehydrogenation. But tertiary alcohol takes dehydration reaction. Dehydration hydration reaction. Why? Because carbon does not have, now for example here tertiary alcohol I just mentioned so that it will be easy to you understand. CH3 here, CH3 here, OH. So here carbon connected with the hydrogen, carbon connected with the hydrogen, that is connected with OH. This also carbon connected with the hydrogen, that is connected with OH. Whereas here carbon connected directly to that OH bond. So it does not have a hydrogen to support. So naturally it does not release, it cannot release that hydrogen, whereas it releases the water molecules only. That is what I mentioned. Dehydrogenation, it does not take place. Why? Dehydrogenation, it releases hydrogen, but dehydration, it removes water molecule. So what happened? The same here, Cu 573 Kelvin. So here you will get alkene product. You know what it is? CH3, here CH3, double bond CH2. Here 2-methyl propene. 2-methyl, 2-methyl propene. Propene. See here, one, two, three, double bond, so 2-methyl propane. Okay, what is the next subproduct? It is water molecule. Why? Because here water molecules releases, because it is hydration. Dehydration means that naturally water removal will be there. Dehydrogenation is there means that definitely there will be hydrogen removal will be there. Hope you are clear all these points. Please, if you want, you can take that screenshot. Primary alcohol undergoes that red hot copper gas passed over to that alcohol, you will get aldehyde. Secondary alcohol, you will get that ketone, whereas tertiary alcohol do not take part in the dehydrogenation. Why? Because it does not have that hydrogen support, so directly carbon connected to that OH bond, so you will get that dehydration reaction takes place. So you are getting water molecule as a subproduct, so you will get alkene product. Here aldehyde and ketone, but here alkene product. Why tertiary alcohol do not take part in that Dehydrogenation, it takes part only in that dehydration. They may ask the question, they cannot give direct answer. Why can't tertiary alcohol do not take part in that dehydrogenation reaction? So I hope you understand this point. Thanks for watching.